Welcome you all to this video lecture on Python modules and packages. In this video, we will be discussing about the Python modules and how to create the user-defined modules and a few examples of built-in modules, and then we'll see how to create a package. To start with, first of all, we should know what is a module. Before that, we know what is a function. So function is meant for reusing, if a part of the code need to be reused, so we will be using the functions. For example, if we take this as a function, this is a function 1, so this is function 1, okay, and we would have written some function, we would have written some logic here, right? And then together, again what we will do is that we can have multiple functions, right? So here I am having some other function, so I'll name it as function 2. Okay, so these are the different types of functions we have, right? So since here Python programming is an object oriented programming language, so along with functions we might have some classes also. So to be more specific and more clear, modules is nothing but the collection of all the functions, packages, functions and different modules and the classes together, we call it as the module. This together we can call this as a module. This is what is called as the Python modules. To start with, Python modules is nothing but refers to the Python file. Okay, so this Python file will contain a statements, classes, functions, variables. So a file with Python code is defined with the Python extension. I will see one example there. So for example, if test.py, so here this module we call it as a test module. Here we will be having different kinds of functions and together we combine this to be a module. So benefit of using the modules is that flexibility to organize the code, then code reusability and helps to debug the code. When it comes for types of module, we have built-in modules and user-defined modules. So first, built-in modules means which will come default during the Python installation, and one of the most widely used, we have few widely used built-in modules in Python. That is nothing but datetime, OS, math module, and then this is module, random module. These are the different kinds of modules that we will be using in Python. So then user defined modules is that what we create, right? So we are going to define, so for example, if I take a math module, let me take an example for this random module. Here we know how to import a module. So import keyword followed by the module name. Then I'll be using this module name random dot rand range of. So this is one of the function which is present in the random module, which is a built-in module. So if I run this, so it will generate some random range between 3, 9. Yeah, each time if I run, so it will generate some random numbers. For example, if I give it this as 29, so this will be generating some random numbers. Similar to it, rand int means this will generate the random numbers between the given range, but it will generate only the integer numbers. Okay. And similar to it, random choice we have. In random choice, what we can do is that we may have a list. Okay, so this is a list. I may choose any one things random. Random means choosing it at a random basis. We don't have any specific criteria or condition. So for example, if this is what is my list, which is containing 3 different elements. If I give random dot choice of my list, so this will randomly choose some values from the list. Okay. Similar to it, sample. Sample means choice means one. Sample means from that entire, for example, 72 students were there in the class means if I want to randomly choose two persons for any event. So what I can do, I can give the entire student's name or roll number, whatever it is. Then I can take random dot sample of the entire student list, comma. If I give k equal to 2, it gives two students. So for example, here I am having my list which is having some 6 departments. If I give it is generating CB and triple E. Next round it will be generating some other different things, right? Like this, triple E and IT. So then if I change this, for example, if I change this to 3, it will be generating 3. So this is what is a sample. Sample means more than one. We call it as a sample. And then this random, it will generate some random numbers between 0 to 1, right? And here we used to follow this thing called as a guess game, right? So I'm taking, we have two different types of modules that we have. One is built-in and user-defined. Built-in, I'm taking a random module as an example and I'm explaining here. So I think most of us would have played the guessing game, right? Here I am just importing the random module. Then I am defining one function, okay, guess game function, which is in this function I am generating the random numbers between 1 to 10. And I'm asking the user to enter number. Okay, what I need to do here is that I need to check whether the user entered number is the random, whether both the matches or not. Okay, here I am generating one random number. Maybe it generate the random number as 5. I'll be entering it as 6. So if both are equal, I'll say, yeah, correct. You guessed it correct. Otherwise, wrong. The number is what. So this is what a simple uh, application where we can use this random module like this. I'll be entering it as 5. So yeah, wrong. The correct number was what? Right? So here I may give the correct number. So here I'm just giving the correct number. So I'll be entering correct number. Yes, maybe 5. So I have guessed it correct, right? And the next time if I'm guessing it no, wrong. The correct number was 2, which means the random number which is generated is 2 here. This is one application where we can use the random number. Another application where we will be using is that we are more frequently would have come across this call. Whenever we go to any other websites, there will be one thing called as an CAPTCHA to verify whether I am a human being or not. For that, each and every website, apart from giving the username and password, we are supposed to enter the CAPTCHA, right? So, how this CAPTCHA has been generated? So, usually CAPTCHA will be having some numbers and the character, which means an alphanumeric thing. So, using a simple 4 lines of code, I can generate a CAPTCHA like this. So, int random, and I'll just importing here. See, I'm using two built-in modules. One is random, another one is the string. Okay, so I'm just defining my user defined function called captcha, and this I'm just generating the character. So as I said you before, your captcha can be a letters, ASCII letters, A to Z, and it can be a digit. So I'm just combining. Strings can be concatenated, so which means this will generate digits from 0 to 9, and this will generate characters from A to Z, capital A to capital Z. I'm just generating the combination of these two, storing that inside a character. Then I'm defining one empty string, and here, see to this, uh, this particular character will generate one letter plus one digit, which means, for example, A9, B7, like this it will generate. From this, what I'm saying, I'm just getting the length. What is the length of the captcha you want? Okay. Then what I'm giving is that random dot choice of characters. So this will generate. See here, when I print this, character, you could able to see what you can able to see from A to Z and A to capital A to Z 0 to 9. This is what is the character now. Now this character is holding this entire thing. From this I need to generate some random numbers. Okay, I mean random characters out of it. That for that I have given the length as 4, so it will generate the captcha of length 4. So random dot choice of character. So each and every time 4 means first run it will choose one character, second run second character, third run third character, fourth run fourth character. I'm just appending that to the variable called C. Okay, C plus equal to means it will add at each and every time it will add, and then I'm returning that final captcha, right? So then here it will be returning. From here I'm calling this function by passing the length of my captcha. So here the control transfers through the function, that is the captcha function. Here it will generate this. Next one I am giving it as 5. Okay, then able to see L7QCD. This is what is the captcha that is being generated. So these are the functions which we can use. These are some of the examples of built-in functions where we can generate the random numbers, generate using the random number module. I'm generating the captcha here, right? So I have also used the built-in module called strings also here, right? This is how we can able to make use of the built-in modules. Similar to it, you may ask how I can find the uh, list of functions which is present in the built-in modules. We have one simple thing here. I'm just importing the string here. Then if I use this dir function, this dir is a built-in function which is used to list all the members of the current module. Here my module is string. If I give dir as dir of s, so it will list all the, see, have we used this one? ASCII underscore. We have used this, right? In the previous thing we have used ASCII underscore letters. Can you able to see that? ASCII underscore letters here. This is one of the constant that we have in the ASCII, have in the string module. Similar to it, we have digits. These are the built-in attributes that we have in the string module. Like this, you can able to list all the inbuilt-in modules. If you want to know what are the functions, we can use this. For example, I may change this to math. Otherwise, I'll include. So here I'm just import math as m and then dir of m. Now if I run this, can you able to see these are the functions that we have in math module. Okay, like this I can create my own user defined, similar to this, similar here math module, random module and string module. I can create my own user defined module. So we'll see how we can create this user defined module now. So to then start with, what we can do is that I'll give a short introduction here. User defined modules, which are user itself will create our own modules. Like we can define, we can create a class, we can create a function, we can even create a small code, and we can combine that to a module. So here, this is how we will be importing the modules here. We have different syntax. First syntax is that we'll just give import keyword followed by module name. Next syntax is import keyword followed by module name as alias name. For example, if my module name is like calculator, so giving calculator is a bit an big name, so I cannot use it, that particular big name. Using that only, using the module name only, I could able to access all the functions inside that. Instead of giving calculator dot add calculator dot subtract, what I can do is that I may give some alternative name for that. So import module name as I can give the alias name. So first two things that we will be more frequently using to import a module. For example, if I need to import a particular function or particular class name from the module, I can go for the third syntax. From module name import, if I want to import only the specific function called factorial or specific function called add, I can go with that. Instead of importing the entire module, I can import only the function whichever I want. When for that, I may use the third syntax. Okay, and similar to it, with the third syntax, I'm just giving the alias name for it. Okay, similar to it, the last syntax is similar to the first one. From module name import star. Star means it will import all the functions, all the attributes over there. This is how we can import our built-in modules or the user defined modules, the basic thing. Now we'll see how we can create our own module. Right? Here I've created my module called div. I'll show how I've created this particular module. Here I've created a div. So here can you able to see here, this one I have defined one function called divide. Div a comma b return a bar b. So this print function, this will just print the name of that module. So I'll write this function and I'm saving this file as divv.py. Now this is my Python file which is having a function. Now this Python file itself is going to act as a module here. Okay, so here div.py. So after giving this, save it and then compile. So file and then just give new terminal. So my function name is, so after giving the function, save your file with one file name. I am saving it with divv.py. So then come back to the terminal, then give python space divv.py. Execute this. Can you able to see the main function here, right? So now the program has been executed. Now come back to my program where I need to use the module. So import. What is my module name? Divv, and I am giving the alias name as d. Import module name as alias name. So my module name is divv as d. Now d dot, what is my function which is there? D, which is taking two parameters. So d dot this alias name dot div of 10 comma 4. And then if I execute this, this will be running. As of now I'll just remove this and I'll execute this alone. Able to see the result as 2.5. See, for example, if I am giving 20 divided by 4, you will get the answer as 5.0. Okay, which means this, when I call this function, it goes to my divv module, and now this function is being called here and it is executing. Now it will result the, which means it will return a divided by b, which is 20 divided by 24. 20 divided by 4, which is 5.4. This is how we will be importing my own module. And here another one example similar to it, what I can do is that dir of d. Dir of d, if I give this, can you able to see the function which is, see, these and all will be a default one. Okay, first few 5 to 6 things will be a default one. And can you able to see the function div which I have defined there? This is how dir, which is used to list all the classes, modules, attributes, variables and functions which is present inside the given module. Okay, so I'm just displaying what is present inside the divv module. Okay. Similar to it, I have also created another one module called mymath1. See here, I'll just show you how many files, how many functions would I have defined here. In my mymath module, I am giving the name of this module as mymath module. I'm just giving it. Okay. See, whenever this is what is the name, whatever the file name will be the module name. Okay. Remember that. Here I am defining one function called add, multiplication, increment, then factorial of a give, finding a factorial. Then I am giving the another function called digit count, then number reverse, then Fibonacci, generating the Fibonacci using for loop, Fibonacci using recursion, then power. So these are the functions which is compiled in mymath module. Okay, so by default we have math module, but I am creating my own model. So here I have listed all the functions whichever I want. Around 6 to 7 functions I have defined. I am just saving this file as mymath1.py. After this, what I said, just go to file and then go to terminal. Just just execute this file. So Python space mymath1.py. Okay. If it should not have any errors. If there is error, we need to rectify it. Okay. Now here import. What is my module name? Module name is nothing but the file name. Don't confuse with this name. Okay. This is my module name. mymath1. Don't give .py. mymath1 will be the module name. mymath1 as m1. Now, what is this dir of m1 will do? It will list all the modules which is present inside. Can you able to see here? We have add, digit count, fact, Fibonacci for, Fibonacci recursion, increment, multiplication, name, then number reverse, power of the recursion, all these things we have. How will you call a function? If I give m1 dot name, what is my name that I have given there? Math module. My math module. This is what is the name. Can you able to see the name here? Then m1 dot add of. M1 is nothing but the alias name for my module. M1 dot add of 1, 2, 3. So the result will be 6. So all these functions, whenever I call this function, the control will be transferred to this math module. Okay. Now all the functions will be, each and every function will be called and the result will be written back here. Okay. This is how we can create our own modules. Okay. So I'll just recollect it. So if you want to create your module, so module is nothing but it may have the variable. See here, I will use one variable also here. So I'll give age equal to 25 and then mark equal to 99.8. Okay, save it. So here these three are the variables and remaining are the functions. So modules may have, module means it may have a variable, it may have a function, it may have a class, all these things together. If I put all these together in one file, and if I'm using that file, I may use that file as a module. Okay, this I'm just saving here, coming back here, and I'm trying to print it. So I'll just give here, right? So name, and I'm just giving print of m1 dot. So before this, save it and go to your terminal. Please execute this code once and then come back here. M1 dot. I'll be giving the age there. Okay, what are the variables that I have used? Age. I'll just give age here. Okay, see here, this need to be executed once. Okay, it will take some time for the execution, right? So for compilation it will take some time. So once it is done, you can able to view what is actually present there. Okay, as of now we got the name, right? Okay, it will take some time for us to view. Okay, so like this you can use modules, you can use functions, whatever it might be, need to be reflected here. That is why it is taking some time. Once it is done, you can able to view the result over there, right? Since it is not yet compiled, I am not getting the result here. Once it is compiled, you can able to view. So this name is nothing but the attribute, right? This is the variable name which I have used here. That is what I am getting here. Okay, right. This is what is the module is about. So module means you can create our file, put all the you can have the variable, you can have the functions, whatever together you can have it in one Python file. And that Python file, if you want to make use of it as a module, just give the name. Okay, we are just giving the name as mymath1.py. Save it, then go to, please execute the file once and then come back here, import, give your module name. Module name is nothing but the file name. Okay, mymath1, as give some alias name for that. Using that alias name, you can access all the functions and variables which is present inside that user defined module. This is how we will be creating our user defined module. Okay, so when I talk about these things, um, modules and packages. So first we started with the functions. So we know how to declare a variable, we know how to write a small program which is having a variable and a function also. So what as of now what we have done is that we have taken the names and the functions together and we have compiled it as a module, one module. Like this, I may have the packages also. To make it very simpler, first we'll see what is this package is all about. So Python packages. So here, Python package is nothing but it is same as the sub packages and the directory or the folder containing some packages and modules. So here only one math module was there. I may have n number of math modules. All these math modules combined together, we call it as the packages. That's it. So to make my folder or the directory to act as a package, Python package, I need to give this file called underscore double underscore init.py double underscore. This is what is the file which I need to give. Okay, so this file may be an empty file or it may or may not have some values. If so, if you need to define any global variables which is visible to the entire module or all the classes which is present inside the package, I can give it in the init.py. If it is not, it can be an empty file. To make it clear for you, so we have a function, one function we know, and we may have multiple functions. This multiple functions together, this multiple functions together form a module. Okay, and similar to it, we may have n number of modules. Okay, not one, we may have n number of modules, and all these n number of modules compose a package. Okay, one function, many functions together form a module, and many modules together form a package. I think this is what is all about. And all the packages, and this is also very important, and all the packages together form a library. Function, many functions form a module, and we may have many modules. All the modules together form a package, and not only a single package, we may have a multiple package which together forms the library. Okay, so we know pandas library, numpy, all these are the libraries. So which means that numpy or pandas library will be having many packages. In that package we will be having many modules, and in one of the modules we may have many functions. This is what is the hierarchy of your Python packages is all about. So I'll just say how to create this Python package and what is it? Yeah. Just assume one small example. I'm going to create a package called calculator. Okay, and this calculator can perform what our normal system calculator will do. It will do a scientific calculation, right? So if I take a calculator, yeah. So this is a normal calculator. If you click on this, you can able to view a standard calculator, right? Standard calculator which will perform addition, subtraction. And when it comes for the scientific calculator, so it will perform some exponential, root of, square root of, log, all these things. And we have one thing called as a programmer calculator. So these are the different kinds of calculators, operations that we can perform in a calculator. Having that in a mind, I'm just creating my own package called calculator. And this package is going to have a multiple modules like basic calculator module. One thing, first one, it may have the one thing called basic.py. Okay, this basic.py is the package, right? This is a module, right? And similar to it, apart from the see here, what I'm trying to here is that create is that I'm just going to create the standard underscore calculator as one package, and the scientific underscore calculator as one package, and programmer underscore calculator as one package. And this package, the standard calculator package, is going to have two modules. Similar to it, scientific is going to have two modules, programmer is going to have one module. So I'm going to now I'm going to say how to create a package for this. Okay, it's very simple. So as I said you before, right? So all these packages, if I need to treat all these things as a package, yeah, I said that this is one package. Scientific, here I have created three packages. Assume that scientific, standard, and programmer. To actually, and these different packages is having two to one modules in that. If I want to make this three packages acts exactly as a package, I need to create one folder called init.py, as I said before. Okay, so standard calculator should have one init.py, scientific should have one init.py, and then programmer should have one init.py. Then now we have three packages. Together only I am saying this is calculator is an overall package. So this calculator should also have the init.py file. Okay. So here, when it comes for the packages, yes. So I'm just going to my folder. Can you able to see? I've created one folder called calculator. If I get into it, can you able to see the init.py file? This is what I said. This calculator should have init.py. See, this init.py is an empty file. You may or may not have some values or not, or it can be just an empty file. I've created just an empty file. How to create it means just click on this new and you can create a new file, and you should save it with double underscore init double underscore dot py. Okay, and here what is our structure? We are going to have three packages. One is standard, scientific, and programmer. And here I am creating three folders: standard, scientific, programmer. If I click on the standard, I may have three different things. One is basic.py, other.py. I'm having three things. Basics.py will hold all the basic functions like addition, subtraction, multiplication, division, modulo, power, division, and 10 to the power, these things. And similar to it, this is having some other things like addition, subtraction, and division is there. And then my math.py, which is going to have some other operations like count, Fibonacci, for factorial, all these things will be there. This is what I have created. I have created my own. In the previous example, I said all we have discussed about the my math which I have created. Okay, these are the functions which I have included, right? So I am using the standard calculator will perform all these things. Now, the standard calculator itself is a package. Am I right? So it should have init.py file. So I am creating init.py file. Then similar to it, what is the second package? Scientific calculator. So come back to the calculator. You're able to see one folder called scientific calculator, and this is going to have trigonometry.py. That is some trigonometrical functions like sine, cos, tan, all these things will be here, right? Here. In this, can you able to see in this particular trigonometry function, I am just calling this math module. So user defined module can have some predefined modules also. Can you make use of the predefined modules also, right? Yeah, this one file. And then other calculations, scientific calculations that might include, can include square, absolute, exponential, power, log, q, exponential to the power of o, whichever that you want you can include. Okay, and can you able to see scientific calculator? This is also one package. Okay, so I have defined two things. One is trigonometry.py and other calculations.py, and the scientific calculator. These two modules together form one package. So if scientific calculator is a package, I need to have this init.py. Is there? Done. Now next one, what is the last one that we have is the programmer calculator. So programmer calculator created one folder. Then inside this program.py, so just define very simple functions like number system and or XOR NAND, not, lel shift, right shift, all these things, very basic things I have done. And then this programmer underscore calculator is also a package. So it should also have the init.py. So I have given init.py. Now, as of now, we have created these three packages. This is standard, scientific and programmer calculator we have created. Okay. And all these packages together only forms the calculator. So now the calculator is also a package. Am I right? Which is a main package. So this should also have the init.py. Okay. Right. Now we have created the module. We have combined two modules, formed three different packages. Two modules we have combined and formed three different packages as standard calculator, scientific calculator, programmer calculator. Now I am having all these three packages in one main package called calculator. Now we'll see how to access all these modules and packages and all. Okay. Now we'll take this as an example. Here, import. Okay, where you have the programmer calculator. Yeah, okay, so here when it comes here, so where we have calculator, inside that we have a programmer calculator, right? This is my calculator package. Okay, inside this I have the programmer calculator. So how I will be calling that particular package? So main, what is my main package name? Calculator dot programmer calculator dot. So inside that what I have? Inside this programmer calculator, in what is the module name? Program.py. So here, this is what I have given here, right? Program as pp. So which means I need to make use of these functions which is present in the program module. So I want to access XOR NAND not module now. Okay, all these functions I need to access. So I know these things are there in the program.py module. Okay, so I need to make use of this module. Okay, so what I can do is that my main module dot program underscore calculator, then the module name as pp. Similar to it, if I want to access, see here, if I want to access the scientific calculator, okay, which means this function, trigonometry function. For example, if I want to make use of the sine, okay, what is my module name? trig, which is present in the package called scientific underscore cal, and this scientific underscore cal is present inside the calculator package. So what I can do here, calculator dot scientific calculator underscore import other as os, other calculations as os, and trigonometry calculations as ts. I can give separate alias names also. Similar to it, I am just importing the standard calculator. In that I am importing the module called basic. Okay, so this is how we can create a package and we can import the modules whichever that it is present inside the package. Now in this example, there is a main package and we have three sub packages, and inside three sub packages we have two modules inside that, and each module is having 5 to 6 or 10 functions is present. Okay, so function combined, modules combined as a package, and sub packages and some other modules combined form as a main package called calculator. Okay, and then I have given one simple calculator program here which makes use of these operations. Just see here. So I'll be importing. So no module name is which I need to create it, right? I will be creating. I have created. Just I need to compile all the things. So then this will perform the scientific calculations of all the things. Okay. So before executing all these things, we should be compiling all these files. Then only it will be executing. Okay. So here calculator. So when it comes for calculator.init.py, so before this I need to execute all these code, and then if I execute this one, you can able to see the output. So it will be asking you to enter the modules, and then you can import. So we have already created the my packages, different packages. I'll just execute this. I'm just importing this. See here, and yeah. So this is what is my package is about. So I have created the calculator package, and I am just creating one file called calculator.ipnby file. So here I am just importing this calculator. Just click on this and give control enter. So which will execute this code. Okay. Now before, if there is any error, it will show, otherwise the calculator package is being successfully imported. And I have explained this program already. I'm just trying and just execute and tell you how it is working. If I run this code, so 1, 2, 3, I'm having 3 choice. I can choose standard or scientific, and just as of now I'm just using the standard calculator, and these are the operations which can be performed. Just I'm giving 4. I'm just going to perform multiplication, then just give 5 and 6. Can you able to see the answer here? So which means it is calling the multiplication function which is present inside the standard calculation. Standard calculation is having the module called basic.py. See here, it will go here, calculator package it will go, then in the standard calculator it will go, then basics.py. In basics.py I have the multiplication function. Okay, so if I give this, if I'm giving this option 4, so it will come to the case, which case here, I mean the else statement which I have given here. So st dot multiply of st is nothing but my standard underscore packages name, that is the alias name which I have given that. I have called the module called basics here. Okay, so this basics module will be called, and inside that st dot multiply means this function, multiply function will be called, and it will take the values that which I have entered here, right? I have entered 5 and 6. Similar to it, you can also perform some other operations, like if I give 2 scientific operations, I can perform 2 basics and trigonometry. I am giving 2, so I can perform sine, cos and tan. For example, if I give 5, can you able to see the sine, cos and tan value of it. Okay, similar to it, I may use the programmer. So for converting from binary to octal, so I enter the decimal value. So if I enter the decimal value, it will convert to binary, octal and hexadecimal. Okay, so from this I have just developed a simple package, a small application of calculator using this. This is how we will be creating the packages combining all the modules. Thank you.